Hello, welcome to my presentation video on arc fault protection in cables and connections. My name is Martin Hlavečka and in this video I'm going to talk about two types of arc fault, the situations in which arc fault occurs, the technology of arc fault detection device, and their types of construction and installation. When a cable is damaged locally or an electrical connection becomes loose, two main types of arc faults start a fire: series arc fault or parallel arc fault. Series arc fault results from an arc between two parts of the same conductor. Whenever a conductor is damaged or a connection is not tightened properly, a localized hotspot occurs that carbonizes the insulating materials in the vicinity of that conductor. Carbon, being a conductive material, allows the flow of current that becomes excessive at various points. Since carbon is deposited in a non-homogeneous way, the currents that pass through it generate electric arcs to facilitate its movement. Each arc then amplifies the carbonization of the insulating materials, so a reaction occurs that continues until the amount of carbon is high enough for an arc to spontaneously ignite. Parallel arc fault occurs between two different conductors. Whenever the insulating materials between two live conductors are damaged, a significant current can be established between the two conductors, but it is too weak to be considered a short circuit by a circuit breaker, and it is undetectable by residual current protection devices since this current does not go to the earth. By passing through these insulating materials, these leakage currents optimize their path, generating arcs that gradually transform the insulating materials into carbon. The common characteristic of these phenomena is the ignition of fire by arcs, so detecting the presence of arcs is a way to prevent them from becoming a disaster. These phenomena can occur in the following situations. The arc fault detection device technology makes it possible to detect dangerous arcs and thus protect installations. Such devices have been deployed successfully in the United States since the early 2000s, and their installation is required by the National Electric Code. Since 2013, the IEC standard 62606 international standard defines arc fault detection devices which detect the presence of dangerous electric arcs and cut off the circuit's power supply to prevent initiating the first flame. Speed is of the essence as an electrical arc can degrade in a flash, igniting any nearby inflammable material and causing a fire. According to IEC 62606, arc fault detection devices must react very fast in case of arc faults and isolate the circuit within a limited time. The arc fault detection device monitors in real time numerous electrical parameters of the circuit that it protects to detect information characteristics of the presence of dangerous electrical arcs. For example, the current of the arc, the duration of the appearance of the arc, the irregularity of the arc, the distortion of the current signal at the time of its zero crossing, the presence of disturbances and varying levels of different high frequencies. On this slide, you can see the general principle of Schneider Electric arc fault detection devices and the anomalies in electric currents that could indicate the presence of potentially dangerous arc faults. On this slide, you can see the distortion of the current signal at the time of its zero crossing. The current flows only after the appearance of an arc which needs a minimum voltage to be created. AFDDs are assembled with a disconnection system that interrupts the current in a case of an arc fault, thus they prevent fire from starting. According to the IEC 62606 standard, three types of construction of arc fault detection devices are listed. The first type is AFDD as a single device, including an arc fault detection unit and opening means, and intended to be installed in series with a protective device which can be an MCB or RSBO. The second type is AFDD as one single device, including an arc fault detection unit and a protective device such as MCB or RCBO. And the third type, arc fault detection unit, can be assembled on site with a protective device such as MCB or RCBO. Arc fault detection devices are designed to limit fire risks caused by the presence of arc fault currents in the final circuits of a fixed installation. They are installed in electrical switchboards to protect circuits supplying power sockets and lighting, and are especially recommended in cases of renovation. Since 2014, International Standard IEC 60364 has made the following recommendations surrounding the installation and application environments of AFDDCs in residential and commercial buildings. In location with sleeping accommodations such as hotels, nursing homes, and bedrooms in homes. In location with risk of fire due to high quantities of flammable materials such as barns, woodworking shops, and stores of combustible materials. In location with combustible construction materials like wooden buildings. In fire propagating structures like high-rise buildings. In locations where irreplaceable goods are housed like museums. It is recommended that AFDDs should be installed at the place of origin of the low voltage final circuit to be protected. More specifically, the installation of the AFDD is highly recommended to protect circuits with the highest risk of fire, such as protruding cables, outside cables, unprotected cables in secluded areas like storage rooms, or aging, deteriorating wiring or wiring for which the connection boxes are inaccessible. The table below tries to position the different types of current-based protections required or recommended for low-voltage installations. We come to the end of this presentation. Thanks for watching.